Hi there and welcome to the channel. In the previous videos, we've dealt with various aspects of complex numbers. For example, we dealt with addition of complex numbers, division of complex numbers, multiplication of complex numbers, the modulus, the argument of a complex number, expressing a complex number in polar form and in exponential form, etc., etc. And we did solve a couple of problems related to complex numbers. In this video, we would like to solve the problem of raising a complex number to some power. I do have a complex number which you can see on the board. I've called it the complex number Z, and we want to raise it to the power 8. Now, we have to use what is called Moivre's theorem. I'm not so sure if I'm pronouncing it correctly because it's a French name, but it's spelled like this. It's a Moivre's theorem. As you can see, it's a French name. He was a French mathematician. And this theorem says, if you have a complex number Z, and it's written in polar form as R cosine of theta plus I sine of theta, and you raise it to the power n. Z to the power n, that's what the Moivre's theorem says. It says this is equal to R raised to the power n, brackets, cosine of n theta plus I sine of n theta. That is the Moivre's theorem. In other words, when you raise Z to the power n, you raise R, of course, is the modulus of Z. The modulus is raised to the power n, and the argument theta is multiplied by n. Okay, so that is the Moivre's theorem. So in order to deal with the problem on the left board there, it is obvious that we need to pass through the process of converting this, which is in standard form, into polar form. So why don't we do that? We are going to write our Z over here and do our calculations on the right board, on the left board. Sorry. So Z is equal to 8 plus 15I. Now, we want to convert Z into polar form, from rectangular form to polar form. First of all, we need to calculate the modulus of Z. So modulus of Z, which is written like that, of course, is equal to the square root of 8 squared plus 15 squared, which is equal to the square root of 64 plus 225, and that should add to square root of 289, which from the calculations I did previously is equal to 17. So what it means is that the modulus of Z is equal to 17. Let's write it here somewhere because we are going to need it. Modulus of Z is equal to 17, so that we can get rid of these calculations down here. So there we are. The modulus of Z is equal to 17. What about the argument of Z? We know that arc Z is equal to arc tan, the angle whose tangent is 15 divided by 8. And again, I did some calculations in the background before I came here, and I found this was 61.92 degrees. That is arc Z. So again, let's just write it here somewhere. So theta, we're going to call it theta, which is arc Z, is equal to 61.92 degrees. Okay, so now you can just clear the board here. All right. Now, we can express z in polar form. We know that z in polar form is equal to r brackets cos of theta plus I sine of theta, where r is the modulus, theta is the argument. So this becomes 17 brackets cosine of, let me put square brackets, cosine of bracket 61.92, let me write it down here, it's not going to fit. So it's going to be 17 for our modulus, square brackets cosine of bracket 61.92 degrees plus I sine of bracket 61.92 degrees, close the big bracket. That now is our z in polar form. But what we want at the end of the day is z raised to the power 8. Now, this is where de Moivre's theorem kicks in, because de Moivre's theorem says, if you remember, it says z to the power n is equal to r to the power n cosine of n theta plus I sine of n theta, close bracket. Now, what is r? R is 17. What is our theta? Theta is that. What is our n? Our n is equal to 8. So we just plug in the values and say z to the power 8 is equal to 17 raised to the power 8, big bracket there, cosine of, I'm going to write it like this, 8 times 61.92 degrees plus I sine of bracket 8 times 61.92 degrees, close bracket, and our big bracket there. Notice what is here. 8 is the power there, multiplying our argument 61 point that. And 8 here is the power to which our modulus r, which is 17, is being raised. So this is now z raised to the power 8. And that is de Moivre's theorem for you. Till we see you next time. Bye-bye, and please take care.